Okay, this video we're going to be solving systems algebraically. Instead of graphing, we're actually just going to be using substitution and elimination to solve them and find their points of intersection. Okay, so solving each equation. When it's just lines like this, we can use substitution and elimination. Okay, I would always use substitution if you have a variable by itself. And so in this situation, y is by itself. So anytime I see a y in my other problem, I can replace it with what it also equals. Okay, anytime I take out a letter and put in a number, I have to make sure I use parentheses. Okay, so I'm substituting that equation in for y since they equal the exact same thing. Now, since it's all in terms of x, I can solve it. So I'm going to distribute here and get 4x minus 6. Okay, I'm going to add my 3x. In the same step, I could add 6 over to my other side. So I would get 7x equals 14. Divide by 7, x is equal to 2. Okay, but these are points where they're running into each other. So I can't just stop at x. I now need to find y. So I'm going to use substitution again and take out an x and plug in 2. The easiest equation to plug it into is the top one, but either one should work because it's where both of them are intersecting at. So I'm taking out that x, substituting 2 in now instead of a big ugly equation. So 2 times 2 gets me 4. 4 minus 3 gets me 1. So the point that these ones are going to run into each other is 2, 1. Okay, so we have substitution, we also have elimination. Elimination only works for lines. You cannot do it when it says x squared or x cubed or the square root of x. It only works for lines. Okay, to do elimination, you want them lined up. So x is on top x's, y is on top y's on the same side of the equal sign. So right now, I need to flip-flop these so my x's are on top of my x's. So I'm going to get 4y. I'd have to add that x and add that 4 so that they flip-flop. Okay, also to do elimination, you have to have one positive, one negative for them to eliminate. So I'm going to multiply, let's go ahead and get rid of my y's, and multiply by negative 1. So I now need to distribute that to everything, even past that equal sign. And then I'm going to drop in my untouched equation. So now when I add going down, my y's cancel, and my x's cancel. So I have a 0 left over here, and this gets me negative 16. Will 0 ever equal negative 16? No, so these lines will actually never cross. Okay, my next one, I got a variable by itself, so I can go ahead and substitute it in. Remember, take out a letter, you have to use parentheses. So when I distribute, I get 6x plus 15. I could subtract 6x. Okay, so my 6x is actually cancel on both sides, and I got 15 equals 15. Well, that is true. So this one is actually infinitely many solutions, which means they're actually the exact same equation. There are two lines sitting on top of each other. Okay, my next one here. I cannot use elimination because now I'm throwing in this absolute value bar. So I'm replacing one of the y's. So what I'm going to do is take this and plop it in for the y. If I use parentheses, it's not going to distribute anything, so I'm just going to leave it like it is. And now we got to solve for that x. So absolute value bars, you got to get rid of everything around it, and then we have to go into the split. So that's what my biggest concern is. So I'm going to add 3 to its like term on the other side. So it's going to get me 0. Then I'm going to divide by 2. Cancels on the left side. I don't do it into my absolute value bars. It's like walls. You can't put anything in your absolute value bars. Think of them as walls. Okay, 2/3 divided by 2 is the same as multiplying by a half. So I'm going to get 1/3. And now I go into my split. I've got x minus 4 equals a positive 1/3 x. X minus 4 equals a negative 1/3 x. Let's bring the x over with the other one. Okay, so I'm doing 1/3 minus 1, so negative 2/3 x. My other one, I'm subtracting x. So negative 1/3 minus 1 gets me negative 4/3. Okay, now to get rid of that negative 2/3, it's the same as dividing by negative 2/3 or multiplying by its reciprocal. Negative 3 times negative 4 is 12, divided by 2 is going to get me a 6. Okay, so I multiply by its reciprocal. Okay, negative 3 times negative 4 is negative 12, or 12 divided by 4 is going to get me 3. Okay, there's my x values, but again, these are points. So now I need to pick one to plug it into. I would suggest putting it into the one without the absolute value. So I'm plugging in 6. So y equals 2/3 times 6.
Kristen Ellsworth, please contact the main office.
Minus 3. So I would just type in my calculator, 2/3 times 6 minus 3. I get 1. Now I do my 3. So y equals 2/3 times 3 minus 3. I would get negative 1. So the point then is 6, 1, and 3, negative 1. So make sure you're finding that actual point of where they'd be intersecting at. Okay, my next one, it looks like x is by itself in this, so I could plop this in for x this time. I've got y squared and a y. We're going to bring it all to one side because we're going to end up factoring. So I got y squared minus y minus 2 equals 0. So multiplies to negative 2, adds to negative 1 is negative 2 and 1. So I'll get y equals 2 and negative 1. So now we got to plug it in to find my x. If I plug it in, I could plug it into either one. I could plug them into this one. So when I plug 2 in there, 2 squared is going to get me 4. So the y value is 2. My x value would then be 4 because I plugged it in, because it's kind of like we're doing the opposite this time. Plugging negative 1 in there, remember using parentheses, negative 1 times negative 1 is going to get me a 1, and then that y value is going in its y spot. Okay, my next one, we could substitute this little x in here. Okay, let's go ahead and subtract the 2 over because we're going to need to get rid of that square root to solve. Opposite of square rooting is squaring. So it's gone on this side. That squared tells me that there's actually 2 of them. So I'm going to get x squared minus 4x plus 4. Got to bring everything to one side. So we're going to subtract them over. So I got x squared minus 5x plus 3. Nothing multiplies to 3 and adds to negative 5, so you're actually going to have to use quadratic formula for this. Okay? And your answer that you're going to get is 5 plus or minus the square root of 13 over 2. And then you would have to plug it in to find your y, but if you plug it in for x in this, that's what your y equals. So that's actually your nasty y value as well. Okay. I could plop this in for my y, doesn't matter which way you do it. I've got an x squared and an x, so let's bring it all over with that x squared. So we're going to subtract the 2x, add the 1 to the other one, so I got 1/2 x squared minus 2x plus 2 equals 0. To get rid of that 1/2, we're going to multiply the whole thing by 2. So I've got x squared minus 4x plus 4 equals 0. So multiplies to 4, adds to negative 4 is going to be negative 2 and negative 2. So when I solve it, I get 2 for both of them. When I plug it back in, 2 times 2 gets me 4, minus 1 will get me 3. So their point of intersection is going to be 2, 3. Okay, my next one, that y is by itself, so we're going to plop it in for the y. We're going to go ahead and square that, so it's going to be 16 over 9 x squared. We can go ahead and combine our like terms here. And get 25 over 9x squared. Solving for x, we're going to multiply by its reciprocal. So I get x squared equals 9. Opposite of squaring is square rooting. So my answers are positive 3 and negative 3 that I'm going to have to plug in and find their y's. I'm going to plug it into this one because there's not as much solving that needs to be done. So if I plug 3 in, I'm going to get 4. So 3, 4. If I plug negative 3 in, I'm going to get negative 4. So negative 3, negative 4. Okay, plop it in. We got x squared and an x, so we're going to move it all to the bigger x squared side and see what we can do. So I'm going to get 3x squared minus 3 equals 0. I don't have another x, so I'm not actually going to be factoring. I could either solve it or take a GCF out and factor. If I solve, I'm going to add 3, divide by 3. Opposite of squaring is square rooting, so I would get x is equal to a positive 1 and negative 1. You could have taken a 3 GCF out. It would have been 3 times x squared minus 1. Then you could have done x minus 1, x plus 1, and you'll get the exact same answers when you use ZPP. So we're going to go ahead and plug it back in. So I could pick the bottom equation if I wanted to. So if I plug in 1, 5 minus 1 squared, which is basically 5 minus 1, so I get 1, 4. Making sure I use parentheses, 5 minus negative 1 squared is 1, so 5 minus 1 will get me 4 again. So negative 1, 4. Okay, plop it in. Got x squared and x, so we're going to move it all to my x squared side. Multiplies to negative 4, adds to negative 3 is negative 4 and 1. So when I do my ZPP, I'll get 4 and negative 1. Plugging it back in, I'm going to plug it into my top equation. So 2 times 4 gets me 8, minus 2 is 6. 2 times negative 1 is negative 2, minus 2 is negative 3. Alright, this one. My x's on top x's, y's on top y's, but I can't use elimination because of this circle here. So we're going to get a variable by itself. So let's say I add y here. Now I can put all this in for that x. Remember, when I take out a letter, put in a number like this, I'm going to use parentheses because I'm now going to have to factor this. This is the same thing written twice. So, oop, I forgot that y squared in there. Okay, so I'm going to get y squared plus 12y plus 36 plus y squared is equal to 26. So my y squareds would get me 2y squared. And it looks like they all have a 2 in common that we could take out. Stick it in front. And then we can move them over so we can get our y squared to be alone. Make sure you do it to both sides, because then I got 13. But I still need to solve this one, so we're going to have to bring that 13 over so I can factor. So I've got y squared plus 6y plus 5. So multiplies to 5, adds to 6 is going to be 5 and 1. So when I do my ZPP, I get negative 5 and negative 1. Remember, these are my y values this time, so I'm going to put them in as my y's. So if I plug negative 5 in, I could do my top one there. So x minus negative 5 equals 6. So really it's x plus 5 equals 6. I'd subtract 5 and get a 1. If I plop in my negative 1, 2 negatives would make a positive. I'd have to subtract them, so I would get a positive 5. Okay, don't have a variable by itself, so I'm going to get one by itself. Let's go ahead and let's say we pick y here to get by itself. So I'm going to add 10x. And then we got to divide everything by negative 10. So I'll get a negative x minus 2 is equal to y. That is what I can plop in for that y using parentheses. When I distribute, I'll get a 4x plus 8. Combining like terms, get a negative 7x. We could subtract 8, get a 28. Divide by negative 7, we'll get a negative 4. We got to plop it back in and find our y. Both of them look pretty ugly, so negative 4y. Again, plop it into one of your originals, just in case you did something where you solved and messed up. Always pop it into your original, make it a little bit easier in case you did make a mistake. Okay, so if I plop it in my second one, I got negative 4y plus 44 is equal to 36. Subtract 44. Get negative 8. Divide by negative 4, we get 2. So my points that they would run into each other is negative 4, 2.